In today's lesson, we're going to continue with sequences. If you remember from last week, a sequence is any pattern where there's a rule to go between numbers or pictures or letters. For today, we're going to look specifically at numbers and what are called arithmetic sequences, like arithmetic. An arithmetic sequence is a sequence of numbers where there is a constant difference in the values. A constant difference means that the same number is added or subtracted between each pair of values. As a reminder from the other day, a recursive rule tells you how to find a term from the one before it, and we're writing those in words. For example, we want to identify if the sequence is arithmetic or not. If it is arithmetic, we're going to write the recursive rule. So arithmetic means that the same number is added or subtracted, that there is a constant difference. So we need to look at each of the values and see how they are changing. The term numbers are in the top row, 1, 2, 3, 4, 5. This is the first term, second term, and so on. The values are in the second row. So here, from 7 to 10, we go up 3. And we want to see if that difference stays the same. From 10 to 13, we go up 3. 13 to 16, up 3. 16 to 19, up 3. So here we see that the difference, the amount that's being added or subtracted, is the same each time. So yes, this is an arithmetic sequence. And then we're going to write a recursive rule. We've basically done the work for that already. We said we were adding 3 each time. So the recursive rule is add 3 to the previous term. In the second example, we look at our values and we see that 2 to 4, we would have to go up by 2. Let's try that again. Go up up 2. From 4 to 8, we would go up by 4. From 8 to 16, we go up by 8. I apologize for the writing. Since these numbers are changing, 2, then 4, then 8, and then the next one would go up by 16, since the differences are changing, they're not common, so this is not arithmetic. If it's not arithmetic, you do not have to write a recursive rule. Continue with these examples. In this one, we go 12, 10, 8, 6, 4. So we're not going up by the same number each time, but if we look at the differences, 12 to 10 goes down 2. 10 to 8 goes down 2. 8 to 6 goes down 2, and so on. This is a constant difference. A constant difference can be the same number added or subtracted. So yes, it is an arithmetic sequence. There's actually a couple ways we can write the rule here. We could say you subtract 2 from the previous term, or we could say that you add -2 each time. We'll talk about that when we start writing a different type of rule in a little bit. But both answers would be correct. 12 minus 2 is 10. 12 plus -2 is also 10. And then again, in our last example, we're going to check our differences. If you have any difficulty with the negatives here, well, I can find the difference by taking one value and subtracting the number before it. If I take 0 minus -5, this has gone up 5. 0 to 5 goes up 5. It's a plus. 5 to 10, up 5. 10 to 15, up 5. If you're unsure at any time, take a calculator and subtract a value from the one in front of it. So do 15 minus 10 is 5. 10 minus 5 is 5. 5 minus 0 is 5. 0 minus negative 5 is 5. These numbers are all the same. We have a constant difference. So yes, it is arithmetic. And since it's arithmetic, we can write the recursive rule, which is add 5 to the previous term. The last thing we're going to do today is write a different kind of rule. This rule is called an explicit rule. An explicit rule is a formula that tells you how to find any value if you know the term number. The advantage of this is that we can go and find the 20th term or the 30th term or the 50th term without finding every one before. With a recursive rule, you have to know one value in order to find the next. With an explicit rule, you can jump to any value you want. Every arithmetic sequence has an explicit rule. These are the steps for finding the explicit rule. First, you find the constant difference. Then we're going to multiply that constant difference by n. The variable n is used in sequences because we only have term 1, term 2, term 3. We don't have any decimals. Then we're going to find the value of the 0 term, which I'll explain on the next page, and we're going to add the 0 term to our formula. Here's an example. Our term numbers again go 1, 2, 3, 4, 5, but I left an open space for the 0 term. If we look at our values, 7, 10, 13, 16, 19, we see that it goes up by 3 each time. 10 to 13 goes up by 3. 13 to 16 goes up by 3. 16 to 19 goes up by 3. So our constant difference is 3. When we write our formula, that constant difference is going to multiply our variable n. Now we need to find the 0 term. The 0 term is the one that would come before the first term. So we're going to work backwards. Going forwards, you add 3 each time. Going backwards, 19, we're going to subtract 3 to get the 16. Subtract 3 is 13. 13 minus 3 is 10. 10 minus 3 is 7. So to get the 0 term, I'm going to take the 7 and subtract 3 and figure out that the number that would come before it would be 4. That's my 0 term. The 0 term gets added in the explicit formula. So the formula for this arithmetic sequence is 3n plus 4. What that means is if I checked any of these numbers up here, for example, my 4th term is 16, I can find that by plugging 4. The 4th term should be 3 times 4 plus 4. 12 plus 4 is 16. I can see that this formula works. Here's another example. In this one, we see that the numbers are going down each time. We're taking away 2, taking away 2, and so on. When we have a sequence that is going down, or we think that it's subtracting the same number each time, our constant difference has to be a negative number. This sequence is going down by 2. The constant difference is negative 2. Then I'm going to work backwards to find my 0 term. Going forwards, I subtract 2 each time, so going backwards, I would add 2. 8 plus 2 is 10. 10 plus 2 is 12. 12 is my 0 term. To write the explicit formula, I take my constant difference times n and then add the 0 term. In general, to write these rules, We take our constant difference and we multiply that by n, and then we add the zero term.